In 1980, the Austrian Ministry of Defense mailed a list of 17 requirements to every serious firearms manufacturer in Europe. Heckler Koch received it. Sig Sauer received it. Beretta received it. FN Herstal received it. Steyr, Austria's own national arms company, received it. Between them, these manufacturers had been building military weapons for a combined total of several centuries. Their engineers had spent entire careers inside the architecture of what a service pistol was supposed to be. Heavy, steel, complicated, proven. A 52-year-old man in a small town outside Vienna also received the specifications. He made curtain rods. He had never designed a firearm. He read the list of 17 requirements and decided he would build the pistol anyway. The established manufacturers found this amusing. They would not find it amusing for long. Gaston Glock was born in Vienna in 1929. His father was a railway worker. There was no inherited factory, no family engineering tradition, no dynasty of gunsmiths passing knowledge down through generations. He grew up during a war, was conscripted as a teenager in its final collapsing weeks, came home, finished his engineering education, and took a job with a hand tool manufacturer. He learned materials science. He learned what happens to metal and polymer under stress and repetition across thousands of cycles. In 1963, he founded a small company from his garage with his wife. They made curtain rods, plastic fittings for doors and windows, unglamorous products manufactured with genuine precision. Through the 1970s, the Austrian military began buying field knives from him, then entrenching tools, then polymer components for military equipment. Each contract deepened his understanding of what military procurement actually demanded: durability, simplicity, resistance to abuse, a price that did not bankrupt a peacetime defense budget. In 1980, he purchased an injection molding machine to produce polymer handles for the knives he was already supplying. His earliest employees were not from the firearms industry. They came from the camera industry. They understood precision polymer components and tolerances, measured in fractions of a millimeter, applied to synthetic materials. This was the team. Curtain rods, knife handles, camera technicians, and a garage. What they built in the next 3 months would force every major arms manufacturer on Earth to start over. Glock was at the Austrian Ministry of Defense headquarters discussing his polymer supply contracts when he overheard 2 senior officers talking about the new pistol procurement program. He introduced himself. He said his company could build the pistol. The officers did not take him seriously. He went home and did something that none of the established manufacturers competing for the contract had done. He went out and bought their pistols: the Beretta 92, the Sig Sauer P226, the CZ75, a modern Walther. He brought them back to his workshop, disassembled every one of them, and studied how each was built, where each was strong, and where each carried complexity that served tradition rather than function. Then he asked the people around him a single question: if you could design a combat pistol from scratch with no constraints from existing manufacturing, what would it look like? Within 3 months, he had a working prototype. The pistol was his 17th patent. He called it the Glock 17. The design dismantled every assumption the industry had built over a century. The frame was polymer, not a polymer grip panel bolted to a steel chassis, not a polymer shell over a metal skeleton. The frame itself was a single molded piece of Glock's proprietary nylon-based compound. It weighed roughly 6 ounces. The complete pistol weighed 22 ounces unloaded. The Beretta 92, which the United States military was simultaneously selecting as its next service sidearm, weighed 34 ounces. Glock came in a third lighter than the gun the most powerful military on Earth was about to adopt. The entire pistol contained 34 parts. The Beretta contained over 70. The Sig Sauer P226 contained over 60. Every part Glock eliminated was a part that could not break, wear out, or get lost during field maintenance by a soldier with cold hands in the dark. There was no external safety lever, no hammer, no decocking mechanism. 3 internal safeties worked automatically: a trigger safety, a firing pin safety, and a drop safety, all engaging the moment the trigger reset, all disengaging simultaneously when the trigger was deliberately pulled. Pick it up. Pull the trigger, it fires. Release the trigger, it is safe. No switch to remember, no lever to forget, no manual of arms to master under stress. The Austrian Army's testing protocol was among the most demanding in NATO. The pistol was frozen to minus 40 degrees Celsius, then heated to over 100 degrees. It was dropped onto steel plates, buried in sand, submerged in water, caked in mud, and fired continuously until the barrel glowed. Then it was subjected to overpressure cartridges, generating nearly double the standard chamber pressure. Then it fired 15,000 rounds and was inspected for wear. The Glock 17 passed every test. According to the head of the Austrian Armaments and Defense Technology Agency, it was clearly superior to every other pistol submitted. It outperformed 8 pistols from 5 established manufacturers. The Austrian military adopted it in 1982. The Austrian police followed. The curtain rod manufacturer was now the armorer of his nation's military and law enforcement. The industry's reaction ranged from disbelief to contempt. A plastic pistol from an outsider, selected over the finest steel frame designs in Europe. The Glock 17 did not engage with the contempt, it kept working. Norway adopted it in 1985, Sweden followed. NATO classified it as a standard sidearm. Army after army passed it through their own trials and reached the same conclusion. Then Glock turned to the United States, and the United States was a different kind of problem entirely. American law enforcement in the mid-1980s was facing a crisis. Officers armed with 6-shot revolvers were encountering suspects carrying semi-automatic weapons with 2 and 3 times the ammunition capacity of a police service revolver. Departments across the country were searching urgently for a replacement. Glock hired a sales representative named Carl Walter, who understood law enforcement procurement the way Gaston Glock understood polymers. Walter's approach was precise. He went directly to police departments and offered terms no competitor could match. In some cases, he provided pistols at significant discount in exchange for trade-in revolvers, which Glock resold on the secondary market. The manufacturing cost of a Glock was low enough that the economics worked even at those terms. No other manufacturer could replicate the structure. Smith & Wesson could not give away revolvers and replace them with semi-automatics at a profit. The polymer frame that the industry had dismissed as inappropriate for a serious weapon turned out to be the cost advantage that made the entire market strategy possible. Department after department adopted it. By the end of the 1990s, an independent audit found that approximately 74% of American law enforcement agencies were carrying Glock pistols. In some regions, the figure exceeded 90%. A man who had been making curtain rods a decade earlier had armed 3/4 of the police officers in the United States of America. The polymer revolution that Glock started consumed the industry completely. Within a decade of the Glock 17's introduction, every major manufacturer was developing polymer frame pistols. Smith & Wesson introduced the M&P. Springfield Armory introduced the XD. Sig Sauer introduced the P250 and later the P320. Walther introduced the PPQ. Beretta introduced the APX. Heckler Koch, whose VP70 had experimented with polymer in 1970 without commercial success, returned with the VP9. The steel-framed service pistol that had defined military and law enforcement for a century was finished. The entire industry was building what Glock had built first. The companies that had dismissed the plastic pistol were now defined by it. But they were a decade behind, and a decade in a market where institutional loyalty compounds is a very long time to be behind. Over 20 million Glock pistols have been manufactured since 1982. The design has been refined through 6 generations. Ergonomics, grip texture, trigger geometry, surface treatments. Each generation improved the details. None changed the fundamental architecture. The safe action system, the polymer frame, the 34 parts, the operating principle, all of it has remained essentially identical for over 4 decades. The design was close enough to optimal from the beginning that 44 years of iterative refinement have produced improvements, not reinventions. Gaston Glock ran his company the way he designed his pistol, no unnecessary complexity. The company remained privately held through its entire history, no public listing, no outside investors, no quarterly earnings pressure demanding short-term decisions that compromise long-term engineering. While Colt filed for bankruptcy twice and Remington, founded in 1816, was acquired, loaded with debt, and filed for bankruptcy in 2018, and again in 2020, Glock remained under the control of the man who founded it. He died on December 27, 2023, at the age of 94. The company he built outlasted him intact. The firearms establishment of 1980 knew exactly what a service pistol was supposed to be. They had spent generations learning it, refining it, perfecting it within a set of assumptions so deeply embedded that no one inside those institutions thought to question them. Gaston Glock had no assumptions. He had a list of 17 requirements, an injection molding machine, and no reason to believe the answer had to look like anything that had come before. The curtain rods are gone. The knife handles are gone. The garage in Deutschwagram is gone, but the pistol that came out of that garage is in the holsters of 3/4 of American law enforcement, in the armories of NATO militaries and in the hands of soldiers and officers on every continent on Earth. 34 parts, 22 ounces, and one engineer's refusal to accept that the answer had already been found.